What's up? I'm Vin, and today I want to take a look at this 5th grade practice math test. I'll leave a link to a copy of this test in the description below. So let's get started. Now, just know for this practice test, there are 45 questions, but not every question is included in the PDF, so I will only be going over the questions that are included in the PDF. And first up here, we have Jill and Mark, and we're talking about money. So we have Jill's money. Jill has 4 $1 bills, so that's going to be 4 times $1 like this. And then next up here, we'll just make that a little bit neater. So we have 4 $1 bills, and then we have 3 quarters, and quarters are 25 cents. So we have 3 times 0.25. And then we've got 4 dimes, so plus 4 times 10 cents, but we could express as 0.10. And then 3 pennies, so plus 3 times 0.01 like this. So this is Jill's money. So what we should do here is just add all of this up. We want to expand everything, but make sure, once again, we're using order of operations. We're going to multiply everything before we add, okay? Multiplication before we add stuff. So what we have here is 4 times 1 is 4, plus 3 quarters is 75 cents. So we're going to have plus 0.75. And then 4 dimes, if we did 4 times 0.10, that would give us 40 cents. So we're just multiplying these across. And then 3 pennies is 3 cents, which would be 0.03. So now when you have to add these up, it probably makes more sense here to add this stuff vertically. So we would have 4.00 plus 0.75, and then we're adding 40 cents. And then finally, we're adding 3 cents. Okay, so I would set this up as a long addition question like this. If you had a calculator, then you could just type all this in, but it's good practice here to know your long addition. So 5 plus 3 is 8, 7 plus 4 is 11. We're going to carry down the decimal, and we have to carry a 1 here since we got 11. And then we have 1 plus 4 is 5. So $5.18. That's how much money Jill has. So now we have to look at Mark's money. So Mark, we'll write over here, Mark has, let's see, Mark has 3 $1 bills, so 3 times 1, plus 4 dimes. So that's, we'll make this a little neater, 4 times 10 cents like this, and then 2 pennies. So plus 2 times 0.01 like this. So if we add up Mark's money, we have 3 plus 40 cents plus 2 cents like this. And this you could probably just add up in your head here, otherwise set it up vertically. But if we have $3 plus 40 cents is $3.40, plus another 2 cents would be $3.42. So now the last thing we need to do here is find what is the difference between the amount of money that both of them have. So what we're going to do now is just subtract. We're going to take the $5.18 and we're going to subtract $3.42. So we just do the long subtraction. 8 minus 2 is 6. We can't do 1 minus 4, so we have to borrow here. We're going to borrow and make this a 4, and then we carry the 1. And now we're doing 11 minus 4 is 7. And we're going to carry down the decimal. 4 minus 3 is 1. So the difference in money is going to be choice B, $1.76. So for the second question here, we're going to be adding 2 mixed numbers. And just know a mixed number could be expressed a little bit differently here. We could say 6 3/5. That's the same thing as 6 plus 3/5. And then we could do something similar for the second term here. We could express 3 2/3 as 3 plus 2/3. Now, the reason why I'm doing this is because now I could rearrange stuff. In addition, order doesn't matter. Addition is commutative. So I want to switch these 2 terms here because that's going to make adding this a little bit easier. We're going to have 6 plus 3 plus 3/5 plus 2/3. So now for this part here, 6 plus 3 is equal to 9. And now I'm going to be adding 3/5 plus 2/3. Now, just looking at this, if you really know your fractions, I know that 3/5 is more than half. 2/3 is more than half. So if I add a fraction that's more than a half with another fraction that's more than a half, this sum here is going to be more than 1 or greater than 1. So this is going to be more than 1, which means if I'm adding something that's greater than 1 to 9, I'm going to have something that's more than 10. And the only answer that's more than 10 is choice D. So that's just a common sense way to the answer. But if you want to actually do this a more technical way, then what we're going to do here is we're going to make common denominators for these fractions. So the common denominator between both of them would be 15. So I would multiply this first fraction here by 3/3. So I'm just going to multiply by 3/3. In the second fraction, I would multiply by 5/5. So now what I have is I'm going to have 3 times 3 is 9 over 5 times 3 is 15. Plus I have 2 times 5 is 10 over 3 times 5 is 15 like this. So now this is going to be equal to 9 plus, and when I want to add these 2 fractions together, I'm doing 9 plus 10 is 19 over 15 like this. But now I need to convert this here into a mixed number. So 19 over 15, if I do that on the side and divide, 19 divided by 15, 15 goes into 19 once, but when I subtract 1 times 15 is 15, I have a remainder of 4. So this would be 1 and 4/15 like this. But once again, I could write this as 9 plus, instead of 1 and 4/15, this is 1 plus 4/15. And now when I simplify this, 9 plus 1 is 10. I have 10 plus 4 over 15. And this now I could say is 10 and 4/15, which also matches choice D. Question 3 is all vocabulary. So we have, which two-dimensional figure is always a regular quadrilateral? Now, regular means all sides and angles are equal. So all sides and angles are equal in measure. So this is an important phrase to know in math. So all sides and angles are equal in measure. So we need to look at some of the answer choices here and see which ones do not fit the description. So a rhombus, all sides are equal. However, not all angles are equal. You see how this is an acute angle down here, but this angle up here, the way I drew it, is obtuse. It's more than 90 degrees. So a rhombus does not fit that description. A polygon is too vague. A polygon could be a triangle, it could be a square, it could be a pentagon, but it could also be something like a rectangle. And in a rectangle, not all the sides are equal in measure. You see, the opposite sides are equal in measure, but the 4 sides together are not equal in measure. So this is out. A square fits the description here because a square, no matter how you draw it, no matter how big you make it, what makes a square is all 4 sides are equal and all the angles are equal. They're all 90 degrees. So this is automatically the one. The reason why trapezoid is no good is that a trapezoid here, not all sides and angles are equal in measure. You see how this side over here is shorter than this side down here. These are different measures. So right away, choice D is out. Definitely choice C. Question 6, we have Janelle is making fruit punch by mixing these ingredients here. And we want to know how many quarts of fruit punch Janelle makes. So for this question, we have to know, and this is on the reference page, but we have to know that 2 cups is equal to 1 pint. And then the reference page will also tell us that 2 pints is equal to 1 quart. So this is going to be helpful for this question. And just know that there's not just one way to do this. So the way I'm about to show here is one way to the answer, but there are other methods you could use. So what I did for this question is I converted the last two, 6 cups and 8 cups, I converted to pints. So just know that it's a 2-to-1 relationship here. For every 2 cups, you have 1 pint. So if I have 6 cups like this, what I could do is I could say, I could take the 6 and I could divide it by 2. And that's going to tell me how many pints we have of grape juice. So if there are 6 cups of grape juice, that means there are 6 divided by 2 pints of grape juice. So that would equal 3 pints like this. Okay, so you could see here, once again, for every 2 cups, we have 1 pint. So we just have to divide this number by 2 to find out how many pints we have. Now, for the next one, what we could say is how many cups of apple juice is Janelle throwing in the mix? Well, we take the 8 and we're going to divide that by 2, and that'll tell us how many pints of apple juice Janelle is throwing in this fruit punch mix. So 8 divided by 2 is 4, so that would be 4 pints. So now what I would do is, think about it, we're mixing everything here to make the fruit punch. So I would add up all of this now, but I'm not adding up 5 plus 6 plus 8. I'm adding up 5 plus 3 plus 4 because now everything is in terms of pints. So in total, we have 5 plus 3 plus 4 pints going into this mixture to make the fruit punch. And 5 plus 3 is 8 plus 4 is 12. That is 12 pints. But now we have to think carefully. How many quarts does Janelle throw in the mix? Well, same relationship here. If I want to go from pints to quarts, I have to divide the number in front by 2. So that tells us that Janelle made 12 divided by 2 quarts. And if we do 12 divided by 2, that's going to give us 6. So Janelle made 6 quarts of fruit punch, and that's going to match choice B. Question 7, Shara is building a birdhouse, and she cuts a 6-foot-long board into sections that are 1/3 of a foot long each. How many sections, this is the actual question, how many sections of the board will Shara have when she is finished cutting? So if you just know to do 6 divided by 1/3, then excellent. But if this doesn't make sense, like where is this coming from? Just imagine the actual board that Shara is starting with. It's 6 feet long like this. So the entire board is 6 feet long, but she's cutting them into sections, and each section is 1/3 of a foot long each. So 1/3 is pretty small compared to 6. So you could theoretically just sit here and count by 1/3 until you get to 6, but that's going to take you a long time. You're going to be counting 18 times. But if you want to do this the more technical way, you're doing 6 divided by 1/3. And anytime you divide by a fraction, the technique that you use is keep, change, flip. So I could rewrite this now as 6 times. So I'm keeping the first thing, I'm changing the operation to multiplication, and I'm flipping the second term, the 3/1, like this. So this just works out to, I could say 6 times 3/1, or I could just say this is 6 times 3. Let's just make that a little bit neater. So this is going to be 6 times 3, because 3 divided by 1 is just 3. And 6 times 3 is equal to 18. So how many sections? Sharrow will have 18 sections. Choice D is our solution. Question 13, which value makes the comparison below true? So for this one here, I use the Pac-Man to help me understand inequalities. Pac-Man wants to eat the bigger number here. Some people will use alligators, but I can't really draw an alligator well. So Pac-Man wants to eat the bigger number. So if Pac-Man is facing 0.6, Pac-Man is eating 0.6, which has to be the bigger number. So we need a smaller number to go to the left. We need a number less than 0.6. So A is out because 0.6 would be equal to 0.6, not less than. So this is gone. This one here is not true because 0.7 would be greater than 0.6. So that would not make this true. 0.59 does fit the description because 0.59 is definitely less than 0.60 like this. I just threw a 0 in because that helps it make more sense. 59 is definitely less than 60. So this one would fit the bill. And choice D is out because 0.64 is greater than 0.60. So this would not be true. Choice C is our answer. Question 14, a student completes his homework in 1 hour and 34 minutes. How long in minutes does it take the student to complete his homework? So for this one, we should know that in 1 hour, there are 60 minutes. So 60 minutes is equal to 1 hour. So essentially what we're doing here is we're taking 1 hour and 34 minutes, and we're going to turn this into 60 minutes plus another 34 minutes. So if we add these two together here, 60 plus 34, we have 0 plus 4 is 4, 6 plus 3 is 9. So it's going to take this student 94 minutes to complete their homework. Choice C is our answer. Question 15, we're doing long division here, and we have 2,158, and we're dividing by 26. So for this one here, we say, okay, 26 goes into 2. It does not. 26 does not go into 21. 26 will definitely divide into 215. But my thought process for questions like this, for how do I get a good answer to go above like this, is I think, well, 26 times 10 is 260. I just have to add a 0 at the end. And I look here, 215 is kind of close to 260, but it's definitely less than. If I look at 26 times 9, that would be 26 less than what we have here. And if I were to subtract 26, I could do that on the side here. I could do 260 minus 26. Otherwise, if I wanted to do that in my head, I'm going to do minus 20 minus 6. So 260 minus 20 is 240, and 240 minus 6 is 234. But there's no shame in this here. What I could do is I could just do the subtraction here on the side. I would borrow, make this a 10. 10 minus 6 is 4. 5 minus 2 is 3. And I also get 234. But once again, 234 is too much. So something's telling me here that 8 is going to be a good number to use. So let me throw an 8 up here. And now I'm going to multiply 26 times 8. And I'll do 26 times 8 on the side. We have 6 times 8 is 48, and I carry the 4. And then I have 8 times 2 is 16, and 16 plus 4 is 20. So notice 208 is fine because I can subtract 208 here. And when I subtract 208, I'm going to be left with 7. And what we have now is we're going to carry down the 8. And now I just have to think, how many times does 26 go into 78? And for this one, what I'm imagining here is 26 is almost 25. So this is just estimation tricks. Is almost 25. And I know that 25 times 3 is 75. So something's telling me times 3 would be something that would get us really close to this. I know we're not going to have any remainders here, so it would have to be exact. And another reason why I know 3 is good is that when I multiply 3 times the ones place here, we have 6 times 3 is equal to 18. The number has to end in 8. And notice 78 ends in 8. So that's another little estimation trick here that's telling me that the next number to use here would be 3. But just know, if I ever picked a number, let's say I picked 4 and I multiply and I get something bigger than 78, that tells me I have to erase 4 and I have to pick a smaller number. So I have 3 times 26 now. And if I do 3 times 26, I'll do that on the side. I'm going to have 18, carry the 1. 3 times 2 is 6, plus 1 is 7. I get exactly 78, which means I'm going to have no remainder. So we have this division problem here is going to work out to 83, and 83 matches up with choice B. Question 18, we're talking about a line plot, and here's Miss Torres, who has a box of scraps of wood, and she measures the length of each scrap to the nearest ½ inch. And here's all the lengths of the scraps of wood in this line plot. We want to know what is the approximate length in inches of the scraps of wood when they are placed end to end. So we want the total of all of these numbers added together. So we have just one scrap of wood that is 5.5 inches long. Then we have one that is 6 inches long. Then we have 3 scraps of wood that are 6.5 inches long. And then we have 2 that are 7 inches long. And then finally, we have 1 scrap of wood that is 8 inches long. So there's a few ways that we could go forward with this. It might help in this situation to turn everything into a decimal. Like 5.5 is the same thing as 5.5, because just know 0.5 is equal to 5/10, and this simplifies to 1/2. So how about we just write these in decimal form? So next, we have plus 6 plus 3 times 6.5. I could express as 6.5 times 3 like this. And if I multiply this out, I'm going to have 3 times 5 is 15. I carry the 1. 3 times 6 is 18, plus 1 is 19. So 6.5 times 3 is going to give us 19.5 like this. I just bring that decimal back down. So this one, we have plus 19.5. That's our middle term here, simplified. And then we have 2 times 7 is 14. And then we're just going to add the 8 here. So now we could choose the order in which we want to add these numbers. It makes a lot of sense to add the whole numbers first. So 6 plus 14 plus 8. And if I do that on the side here, I have 14 plus 6 plus 8. Well, just know I'm making groups that make 10. 14 plus 6 is 20, and 20 plus 8 is 28. So now what I have is I have 28. So I just added those 3 numbers together, plus 5.5 plus 19.5. So now I'm going to add these decimals together, and I'll do that on the side. We have 19.5 plus 5.5. And when we add these two together, 5 plus 5 is 10. So we carry the 1. Let's just make that 0 a little bit neater. We bring down the decimal. Now I have 1 plus 9 is 10, plus 5 is 15. I carry the 1. So the sum of the decimal values is exactly equal to 25. So now I have 28 plus 25. And that's the last long addition I'll do on the side here. I'm really using the margins here. So you have 8 plus 5 is 13, carry the 1. 1 plus 2 is 5. So the final sum here works out to 53 inches, and that's going to match choice D. Question 19, we want to find an expression that is equivalent to this expression here. So for this one, we're going to expand 0.15. Just know 0.15 we could say is equal to 0.10 plus 0.05, because we have a 1 in the tenths place and we have a 5 in the hundredths place. So we have 1/10 plus 5/100ths. So that now I'm going to write, instead of 0.15, I'm going to write we have 0.10 like this plus 0.05. And now the next thing that we're doing is using the distributive property. So we have 65 times this sum. So we're going to distribute the 65 to the first part of the sum and then the second part of the sum. So now we could write this as 65 times 0.10. And that 0 at the end is just a placeholder. So I could just leave it as 0.1 like this. And then I'm going to have 65 times 0.05. So now we scan the answer choices here. And I could always just sprinkle in an extra set of parentheses here. I could put parentheses on this. This just says, hey, multiply these two and then add it to the product of these two. So I could just throw in this extra set of parentheses for both. And if we look here, this is going to match up with choice D. For question 20, we're subtracting mixed numbers and we're going to have to borrow here. And the way I know that we have to borrow just by looking at this is when we go to do 1/3 minus 5/8, what we have here is the fraction on the right is greater than the fraction on the left. So we're going to have to borrow from the whole number 14 here. So what I think of here is 14 and 1/3 is 14 plus 1/3. And 14 I could write as 13 plus 1, and I'll just tack on that plus 1/3. So I'm just expanding this out. And then the 1 in the middle, I'm going to express as 3/3, so that when I add it to the 1/3, now I have common denominators. So this I can now write as 13 plus 3 plus 1 is 4. Over the denominator we just keep as a 3. So this now I could say is 13 and 4/3. So the new question that I'm going to be doing here is I'm going to be subtracting 13 and 4/3 and we're subtracting 6 and 5/8 from 13 and 4/3. So now what I need to do here is I need common denominators. So for this one, to find common denominators here, we're going to take 4/3 minus 5/8, and we're going to multiply the first fraction by 8/8, and we're going to multiply the second fraction by 3/3, because the least common multiple between 3 and 8 is 24. That's why I'm multiplying the first fraction by 8/8 and the second fraction by 3/3. So now I do 8 times 4 is 32, over 8 times 3 is 24, minus 5 times 3 is 15, over 8 times 3 is 24. You could even check here if you found common denominators at this step. If you did times 8/8, you would have 8/24. And if you multiply this one by 3/3, this would work out to 15/24. So you see, once again, doing 8 minus 15 would put you into the negatives. And that would make this question a little bit trickier. You could still do it that way, but it's a little bit more abstract. So that's why we borrow from the whole number here, so that our fraction 4/3 is now greater than 5/8. So now this we could express, considering we just converted these fractions into fractions that have common denominators. Now what we could do is we could make one more substitution here. This is now 13, and instead of 4/3, 4/3 transformed into 32/24, and now we're subtracting 6, and 5/8 became 15/24. Okay, so if you could do that step in your head, just do times 8/8, you could get right here, and this one times 3/3, you don't have to write it separately here. So now from this step, what I'm doing, I'm subtracting 13 minus 6. So this is my thought process. I'm thinking, all right, I'm doing two subtraction problems now. I'm doing 13 minus 6, which is 7, and then I'm doing 32 minus 15. I'm subtracting the numerators. Now this, if you could do in your head and you know it's 17, then great. Otherwise, borrow, and you got 12 minus 5 is 7, 2 minus 1 is 1. So I write this out, 13 minus 6, once again, is 7. And when I subtract the numerators, 32 minus 15 is 17, and I keep my denominator of 24. So this one here is going to work out to choice B. Question 21, Trey and his 4 friends equally share a 12-ounce jar of applesauce. How much applesauce in ounces does each person receive? So for this one, Trey is one person, and he has 4 friends. So in total, there are 5 people. Now, the key phrase here is that they equally share. And in math, when you equally share something, you are dividing. Okay, so this is telling us to divide. And they're sharing a 12-ounce jar. So we're going to take 12 and we're going to divide it by 5. So 12 divided by 5 equals. And for this one here, we're going to convert this into a mixed number. So we're going to be doing 12 divided by 5. 5 goes into 12 twice. 2 times 5 is 10. And when we subtract 10, we have a remainder of 2. But the remainder 2 is our fraction 2 over, we were dividing originally by 5. So this is going to work out to 2 2/5, and that matches choice B. Question 22, what is the value of 3/10 plus 27/100? This is equal to 3 plus 27 is 30 over 10 plus 100 is 110. All right, don't ever do this. This is a very dangerous bear trap. The only time you're ever allowed to add fractions is when they have common denominators, okay? We need common denominators in order to add these two fractions together. So this, we're going to have to transform 3/10, we're going to multiply by 10/10. We're going to leave the second fraction alone because the denominator is already 100. And when we do 10 times 10 on bottom, that's going to match the 100 that's on bottom here. So the first fraction, 3 times 10 is 30. Over 10 times 10 is 100. We're adding these two fractions together. Now, this math you could do in your head, or you could do this off to the side. We have 30 plus 27 over 100. 30 plus 27 is 57. So we have 57 over 100, and this is going to match choice D. Question 23, which statement about this quotient is true? So for this, just think of this as 425.378 divided by, and if you know 10 to the third power is equal to 1,000. Another way of seeing this, 10 to the third is 10 times 10 times 10, and that would give you 100 times 10, which is also 1,000. So we're dividing by 1,000 here. And just know, anytime you divide by a power of 10, the power itself tells you how many times to move the decimal. So what I'm imagining here, when I look at this number, when I look at 425.378, when we divide by 10 to the third, or 1,000, this tells us to move the decimal 3 times to the left. So we're going to go 1, 2, 3. So the actual quotient here, if we move the decimal all the way to the left, I'm going to put a 0 in front here as a placeholder. We're going to have 0.425 378 like this. So now we just have to scan the answer choices. The decimal point is located to the left of the 4. That is definitely true. Right away, I could see that our decimal landed to the left of the 4. The decimal is located to the right of the 8. No, this would be the answer if it was times 10 to the third power, okay? But we're not multiplying, we're dividing here. So choice B is out. The decimal is located between the 3 and the 7. No, that would be the result of multiplying by 10 to the first. Then the decimal would move one place to the right like this. So choice C is out, and the decimal is located between the 4 and the 2 would be if we divided by 10 to the second power. Okay, so if we divided by 10 to the second power, then the decimal would move 2 to the left, and it would be between the 4 and the 2. But we're dividing by 10 to the third, so not choice D. A is definitely our answer. So question 31, we want to find the missing value here. And one thing we could do is find common denominators for everything so it's more obvious. So for the first fraction here, I would multiply by 10 over 10, so we get a denominator of 100. So we would have 40 over 100 plus blank over 100 equals, and the fraction on the right here, I would multiply also by 10 over 10 to give us 70 over 100. So now, if we combine the stuff on the left, this would be 40 plus blank over 100 is equal to 70 over 100. So the blank here, what you're thinking of is 40 plus what number equals 70. And if you scan through the answer choices, the answer here would have to be 30, because if you think about it, 40 plus 30 would give us 70, which would match the numerator on the right. Definitely choice D. For question 32, we want to know which expression is equivalent to this expression here. And for this one, it's a little bit strange, but we're not actually simplifying. We're just trying to match this to one of these. So I have 2/3 times 7. And 7 I could write as 7 over 1, because a whole number, if you divide it by 1, is equal to the same thing. And the reason I do this is because now I could multiply these two fractions together. I'm going to have the numerator 2 times the numerator 7. So I have 2 times 7 over 3 times 1 like this. But then the next concept that you need is if I had an expression like this, 8 over 4, this is the same thing as saying 8 divided by 4. And either of these expressions here would simplify to 2. So I'm going to use that idea, and I'm going to write this now as we're going to have 2 times 7 divided by 3 times 1. So I could rewrite a fraction as the numerator divided by the denominator. And now this, if I start looking, this almost matches one of our answers, but now I'm just going to leave 2 times 7 as 2 times 7 and drop the parentheses because there are no parentheses in the answer key. And I'm going to divide by 3 times 1 is equal to 3. And when we do this, you can see this matches choice A. Question 33, just know your vocabulary. A two-dimensional figure that has 4 equal sides and 4 right angles, that would be a square. Okay, so this one here is going to be choice D. Question 34, we want to know which expression has a value less than 1. And for this one, it really helps to know this nice trick. If I had some crazy fraction like this times some other crazy fraction like this over, let's say this, times, and I'm going to make just 2 more fractions. I promise this has a point. We have 1007 over, let's say this, times, and let's give one more, 5 over, I believe, yeah, this will do the trick. So how would you multiply these? You might think, oh no, what if I don't have a calculator? This looks miserable. But 1007 divided by 1007 is equal to 1. If I did 5 divided by 5, that's equal to 1. 176 divided by 176 is also equal to 1. And finally, 1291 divided by itself is also equal to 1. So now when I multiply everything across, that's equal to 1. So the reason I bring this up is because we want to know which expression is less than 1. When I see 3 divided by 3, I'm like, oh, cool, that's equal to 1. 4 divided by 4 is also equal to 1. So when I multiply this across, it's just going to equal 1, which is not less than 1. So A is out. And now when I look at this, 3 divided by 3 is 1, and I'm left with 6 divided by 4. And 6 divided by 4 would be 1 2/4, because 4 goes into 6 once with a remainder of 2. So this would be 1.5. Not less than 1 though, so this is out. Now when I look at this, 4 divided by 4 is 1, and I get 3 on top over 4 on bottom is all that's left. 3/4 is definitely less than 1. So I know right away this is choice C. But let's rule out this choice here to be 100% safe. 8 divided by 4 is 2. And then 3 times 2 is equal to 6 over 4. And you see the same issue that we had a moment ago. 6 over 4 simplifies to 1.5, which is definitely not less than 1. So choice C is our answer. Question 35 is so easy, it's difficult. It's one of those questions you'll either know how to do it or not know how to do it. 0.28 means 28 hundredths. So I could express this as 28 over 100. I don't have to simplify because right away I could see this matches choice C. Question 36, Mr. Davis buys 4 pizzas for a family dinner, and he's cutting each pizza into sixths. So we have 4 pizzas, so there they are. And Mr. Davis is cutting them into 6 slices each. So I'm just going to write here like 6 slices each. All right, I don't feel like drawing like 6 cuts. That's going to take forever. So how many pieces of pizza does Mr. Davis have for a family dinner? Well, this one here, you could do 6 plus 6 plus 6 plus 6, or you could just do 6 times 4. And that repeated addition problem is going to tell you 24 slices of pizza, choice D. Question 37, Nick is drinking a bunch of water. So he drinks 2/3 of a liter of water in the morning, a half a liter of water at lunch, and during basketball practice, he drinks another 2/3 of a liter of water. What is the total amount of water in liters that Nicholas drinks? So for this one, we're just adding these fractions. We have 2/3 of a liter of water in the morning, plus half a liter of water at lunch, and we have 2/3 of a liter of water at basketball practice. So we just have to add these up here. So when I think of these numbers, I look at the denominators and I see we have denominators 2 and 3, and I'm thinking least common multiple. The least common multiple of 2 and 3 is going to be 6. So I want all of these to have a denominator of 6. So the first one here I would multiply by 2 over 2, and that would give me 4 over 6. Plus the second fraction I would multiply by 3 over 3, and that would give me 3 over 6. And then the last fraction here, I would multiply by 2 over 2, and this would also give me 4 over 6. So now what we have is we add the numerators. We have 4 plus 3 plus 4 over 6, and that's going to give us 7 plus 4, which is 11 over 6. And now this, if you could do in your head, great. Otherwise, we'll just do the long division on the side. We have 11 divided by 6. 6 goes into 11 once. When we subtract 1 times 6, we have a remainder of 5. So it's 1 and 5/6. So this works out to 1 and 5/6. Or 5 over 6, that's going to be choice D. Question 38, we're taking this verbal representation of a number and we're writing it in standard form. So for these, my thought process is I break this down in stages here. The first part of the number, the whole number, we have 680. So 680, and now the rest here is the decimal part. We have 14 thousandths. So you have to be careful here. Just know 14 thousandths, don't write this in your head, because this is 14 hundredths, okay? This is equal to 14 over 100, not 1,000. So 14 thousandths would be 0.014 like this, okay? And just know the phrase here, and, when you're talking about a number in verbal form here, is telling us to add these together, okay? Because we have the whole number here, so this is the whole number. So this is the whole part of the number, and this is the decimal part. So we're going to add the whole number plus the decimal part. And just know that when your decimal has a 0 in front like this, you could just combine this as 680.014. So here we are. Our answer is choice C. Just be careful for choice B. This is a very dangerous bear trap. So take a second to read through question 39. We have Callie working at a pet store, and she has to add the correct amount of water conditioner to each fish tank. And we have a list that tells us the number of fish tanks and the amount of water conditioner that she's going to use. So there are 12 fish tanks, and each of them need water conditioner, and each fish tank holds 20 quarts of water. So the first thing I would find is there are 12 fish tanks, and each one has 20 quarts of water. So in total, if you multiply 12 times 20, that's 240. This tells us that there are 240 quarts of water in total in all of the fish tanks. But now, this is the next part we need. For every 10 gallons of water, Callie uses 1 teaspoon of water conditioner. So this just tells us here that for every 10 gallons, we need to use 1 teaspoon like this, okay? So we need 1 teaspoon for every 10 gallons. But notice what we have is we have the amount of water in quarts, not gallons. So here, if you know this, great. Otherwise, go to the reference page. You have to know that for every 4 quarts, you have 1 gallon, okay? So what that tells me is if I want to convert quarts to gallons, I would have to divide the number in front of quarts by 4 to get the number of gallons. So this tells us we have 240 divided by 4, and that would tell us how many gallons we have. And if I do 240 divided by 4, I could do this off to the side here. Otherwise, if I'm doing this in my head, 24 divided by 4 is 6, and then I just tack on a 0 here. So there are 60 gallons in total. But once again, if I have to do the long division on the side, 240 over 4, 4 goes into 24, 6 times 24 is 24. I subtract, I get a 0. I carry down another 0 here, but that just still makes this 0. And then I have 4 goes into 0, 0 times, and then this divides evenly here. So that's where we're getting 60 from. But now we're ready to go forward with this. Remember, for every 10 gallons of water, we use 1 teaspoon. So to get from gallons to teaspoons, notice I'd have to do 10. I would have to divide by 10 here to get the 1. So that tells us here we would have 60 divided by 10 teaspoons that we need to put in these fish tanks here in total. So 60 divided by 10 here is 6. So Callie is going to have to use 6 teaspoons in total to treat these tanks. So question 40, we have the perimeter of an equilateral triangle is 1/8 of a unit long. What is the length in units of each side of the triangle? So this is what we're looking for. What is the length of each side? So for this, the thought process is when you know the perimeter of an equilateral triangle, all sides are equal, and that's built into the prefix here. Equi, just think equal. So I'm imagining a triangle like this, and let's say the perimeter was a nicer number. Let's say something like 36. So 36 units long. If you wanted to know the length of each side, you would take 36 and you would divide it by 3. And that would tell you the length of each side is 12. And if you look here, 12, 12, 12, if you add up all 3 sides, it's going to give you the perimeter 36. So that's when the numbers are nice. But what we have here is we have a fraction. So we're going to take 1/8 and we're going to divide it by 3 because once again, if we know the perimeter, we divide it by 3 and that's going to tell us the length of each side of our equilateral triangle. So now we're dividing fractions here. So I'm going to write this term on the right here, 3, as 3 over 1. And we're going to use the technique keep, change, flip. So I'm going to keep 1 over 8. I'm going to change the operation to multiplication. And I'm going to flip this fraction over here to 1 over 3. And now we're going to do 1 times 1 is 1 over 8 times 3 is 24. And this is going to be the length of each side of our equilateral triangle. Now, if we want to be 100% safe here, what we could do is we could check our work. So to check, what we're going to do is we're going to draw a triangle here and we label each side as 1 over 24. And if we want to find the perimeter, we're going to be adding these 3 sides together. So the perimeter, we're going to have 1 over 24 plus 1 over 24 plus 1 over 24. And when we add these 3 fractions, we're going to keep the denominator as 24 and 1 plus 1 plus 1 is 3. And then if we reduce this fraction, divide the top and bottom by 3, this is going to reduce to 1 over 8, which matches the perimeter that we started with here. The perimeter of the triangle was 1/8. So this answer here checks out. So for question 1, we have this number here, 714.438. And we want to know, how does the value of the digit 4 to the left of the decimal point compare to the value of the digit 4 to the right of the decimal point? So we're focusing on these 2 4s here. And the thought process for a question like this, what I'm thinking about is that the 4 to the left, so I'm going to label here the left, that value of this 4 is in the ones place. So notice here, this is in the ones place. And the 4 to the right is going to be in the tenths place. So on the left side here, that 4 is just equal to 4. But on the right side here, the 4 in the tenths place is equal to 4 over 10, which another way we could say this is 0.4. So now how much greater is 4 than 0.4? Well, if I wanted to get from 0.4 to 4, so I'm going to continue this thought process. To get from 0.4 to 4, I would have to multiply 0.4 by 10. And that would be equal to 4 because I would just move the decimal 1 place to the right, and that would give me this. So now we're just going to construct this into a sentence. Question 42, we have Maddie buys 5 notebooks and 3 pens, and here's the price of each item. And she's paying with a $20 bill. We want to know how much change is Maddie going to receive. So for this, we have to find out how much she's paying for everything. So the notebooks are $2.85 each, so $2.85, and she's buying 5 of them. So we're just going to multiply this by 5. 5 times 5 is 25. We carry the 2. 5 times 8 is 40, plus 2 is 42. Carry the 4. And we got 5 times 2 is 10, plus 4 is 14. So $14.25 is her bill for notebooks. But now we have to calculate how much is she paying for pens. So the pens are $1.79 each, but she's buying 3 of them. So we're going to multiply that by 3. 3 times 9 is 27, carry the 2. 3 times 7 is 21, plus 2 is 23, carry the 2. And then 3 times 1 is 3, plus 2 is 5. So she's paying $5.37 for pens. So now the total bill, so here's the total. We're going to do $14.25 plus $5.37, okay? And this is going to be in dollars, so we could put our dollar sign here, or we could write it at the end. It doesn't matter. So we have 5 plus 7 is going to give us 12. Carry the 1. We have 1 plus 2 plus 3 is 6. We don't have to carry anything. And now we have 4 plus 5 is 9. Carry the 1 down. 1962 is the total bill, but we want to know how much change Maddie is going to get back. So the change, this is the part here where we get our actual answer. She's paying with a $20 bill, so we're going to take the $20 bill here. And well, we're going to write the 20 amount here, and we're subtracting the total bill. The 1962 is being subtracted from 20. So now this, if you could do it in your head, great. Otherwise, just borrow. So we have to borrow all the way at the end here and make this a 1, which turns this into a 10. But now we have to borrow from here to make this a 10. And we have to borrow from here to make this place over here a 10. 10 minus 2 gives us 8. 9 minus 6 is 3. And now we have 9 minus 9 is 0. I'm not going to write another 0. We're just going to say 38 cents is the total change for Maddie. Question 43, Colin built 4 identical towers using unit cubes, and one of the towers is pictured below, and we want to know the total volume in cubic units of the 4 towers that Colin built. So for this, we have to know the volume of a rectangular prism is length times width times height. And if we look here in the key, we're told that one of these cubes is 1 cubic unit, which means it's a 1 by 1 by 1. Because if I multiply here 1 times 1 times 1, that's going to give me the volume of 1 cubic unit. But now what we need to do here is we need to count the dimensions. So going across, it's going across 1, 2. So that would be our length. Our width is going to be 1, 2, and our height is going to be 1, 2, 3, 4, 5. So this is going to help us find the volume of one tower. But remember, Colin built 4 identical towers, and we want to know the total volume of all 4. So for this, the total volume, so now we could write out our answer. The total volume of the 4 towers is going to be 4 times the volume of one of those towers. So here we're going to find the volume by doing length times width times height. And the length is going to be 2, the width is going to be 2 units, and the height is going to be 5 units. So the volume of all 4, now this part you could do in your head. I would choose to multiply 4 times 2, which is 8. And then I would multiply at the end. 2 times 5 is 10. And 8 times 10 is equal to 80, which would tell us that the total volume is going to be 80 cubic units. So here is our solution to question 43. Question 44, we have Sam has a goal of walking 3.5 miles by the end of the day. And he walks 1 1/8 miles before lunch, 3/4 of a mile after resting. What is the remaining distance in miles that Sam needs to walk to reach his goal? So let's think about what's actually happening here. Sam wants to walk this entire distance of 3.5 miles. And right now he walked 1 1/8 miles. So this was how far he walked before lunch, 1 1/8 miles. And this is not drawn to scale. I'm just drawing it to get an idea of what's happening. And then after lunch, Sam walked 3/4 of a mile. And what we're trying to find here is how much does he have left to walk? So for this, what we want to do is we want to add these 2 distances together and subtract it from the total distance. That'll tell us what the missing piece is here. So first up, I'm going to add what is 1 1/8 plus 3/4. And there's a few ways we could go forward with this. Let's do this a different way. Let's convert this to an improper fraction. So I'm going to multiply 8 times 1, and then I'm going to add 1 to that. So I have 8 times 1 is 8. So I'm going to write this, we have 8 times 1 plus, and now I'm going to add the 1 in the numerator over my denominator is 8. And then I have plus 3/4. So I'm just simplifying this here. So we're going from here to here. Now this is going to make 8 plus 1 is 9. So I have 9/8 plus 3/4. And to add these 2 together, I'm going to need common denominators. Let me just make this a little bit neater. So this is 9/8. And this one I'm going to multiply by 2/2. And that's going to give me, we're going to have 9/8 plus, we're going to have 6/8. And now when we add those 2 together, 9 plus 6 is 15. So we have 15/8 like this. So this is how much Sam walked so far. So to find out the remaining distance, I'll just write over here, the remaining distance, we're going to find by subtracting now. So the remaining distance, all we have to do is we're going to subtract, the total goal is 3.5, and we're going to subtract 15/8 like this. So now I'm going to convert this to an improper fraction. So we're going to multiply and we're going to add. So we're going to have 2 times 3, and then we're going to add 1 to that over our denominator 2. And we're still subtracting 15/8. So this is going to make, we're going to have 6 plus 1 is 7. So we have 7 halves minus 15/8. And in order to subtract these 2, we're going to make common denominators. I'm going to multiply by 4/4. So now 7 times 4 is going to give me 28. And we're over 8 like this, and we're subtracting 15/8. So now we finished subtracting here. 28 minus 15 is 13. And now I could do this work on the side. 13 divided by 8. 8 goes into 13 once. And when I subtract 1 times 8, I have a remainder of 5. So this would make 1 and 5/8. So the total distance remaining for Sam to walk here is going to be 1 and 5/8 miles. So this is our solution to this question here. So question 45, our final question here, it has two parts. And first up here, we have two rectangular prisms. We want to explain the process for determining the combined volume of the two prisms. We need to be sure to include the total volume in our answer. So that's the first thing we want to do. And when we're talking about volume of a rectangular prism, we're going to need volume equals length times width times height. So the process here is we have two rectangular prisms. So we have to find the volume of both of them first. Then we're going to add those two volumes together. So we'll write that in our sentence, but let's go ahead and do the math up front. So the volume of the first one, I'll say this is our first rectangular prism. The volume of the first rectangular prism is equal to the length, we'll say, is 5 inches. So 5 inches times the width is going to be 3 inches, and the height is going to be 4 inches. So now we just multiply here. We're going to have 5 times 3 is 15, and 15 times 4 is 60. So the volume of the first rectangular prism is going to be 60 cubic inches. I could write like this, as inches to the power 3 like this. Now I'm going to find the volume of the second rectangular prism, which is the one above. So here the length is going to be 2 inches. So I have 2 inches times the width is going to be 5 inches, and the height is going to be 3 inches like this. Okay, so we're just multiplying those three values together. And now we work this out, just making that a little neater. The volume of the second rectangular prism, we have 2 times 5 is 10, times 3 is 30. So we have 30 cubic inches. So here we want to find the total volume. We're going to say here that the total volume is going to be the sum of these two. So now for the last part of this question, we're told if the figure on top was 4 inches tall instead of 3 inches tall, what would be the difference between the volume of the original prism on top and the new prism on top? So what I would say here is find the volume of the new prism. So the volume of the new prism on top, if the height was 4 inches instead, the volume of the new would be length 2, so we have 2 inches, times the width is 5 inches, times the new height is 4 inches. And if we multiply here, that's going to give us 10 times 4, which is 40 cubic inches. But the volume of the old one, we already found this. The volume of the old, we found before, that was the volume of the prism on top. That was 2 times 5 times 3, was 30 cubic inches. So we want to know what would be the difference if we changed the height of the prism on top. Now we just have to subtract here. It would be 40 cubic inches minus 30 cubic inches. And this would work out to 10 cubic inches. And I'll just write this in the answer spot here. The answer, we would have 10 cubic inches.